Hi, today we have lead code 475 heaters. I'm gonna share screen now. And 475 heaters. Winter is coming. No, summer is coming. During the context, you design a standard heater. A standard heater with a fixed warm radius to warm all the houses. Every house can be warm as long as the house within a heater warm radius range. Okay. Given the position heater on horizontal line returns the minimum radius standard of the heater, so that those heater could cover all house. Okay, minimum radius of heater, so they will cover all houses. Notice model the fit of the radius standard and the warm radius, it will be the same. Okay, so houses 1, 2, 3, we have heater on 2. See, no. 0, 1, 2. The only heater we place in the position 2. Oh, okay, 1, 2. Okay, 1, 2 position. And if we use the radius 1 standard, all of the houses can be warmed. Okay. Is there like we have one? Oh, okay, so this is array with coordinates. This is also coordinate when heater is placed. Okay. So houses 1, 2, 3, 4, heater 1, and heater position 4. Radius 1. So heater in position 1, 0, 1, 0, 1, 2, 3, 4, position 4. Four, 0, 1, 2, 0, 1, 2, 3, 4. Okay, position 1 and position 4. Outbound. The two heaters are placed at position 1 and position 4. This is the radius standard, and all houses will be warm. Example 3, houses 1, 5, heater on 2. So, okay, if we have index 1, 2, 3, 4, 5, 6, and we have houses on position 1, position 2, and position 3, and we have heaters on position 2, then radius is 1. Okay, I can agree with that. If we have houses on position 4 and we have heaters on position 1, and position 4, so this radius is 1. Oh, okay, I got it. So this is radius 1. And this is radius 1. And we have, okay. It's still 1 radius. Okay, and next, if we have houses in position 1 and 5, and we have heater on position 2, then radius will be, here is radius 1, and here is radius 3. Okay, on this example, we see that it will be max of result will be max of distance from from house to heater. So I would say brute force solution will be, we will enumerate through houses, and for X in heater, I will mark heater X. And then what we will do, we calculate distance. HD heater distance will be apps, because it could be left on right, right? X minus H. X minus H and but you see what, if this house is close to heater, right? And we have another heater is here, for example, right? We cannot get this max because this is correct answer and this is not correct. So we cannot calculate max for distance from house to heater. Max of all mean distances from house to heater. So we have to calculate. So, for example, if I create, if I store distances from house to heater in some structure, let's call it, I don't know, house distance, and I will put all mean. Yeah, I will enumerate from houses and heaters, and if house in distance, then I will calculate, because I need to calculate mean heater distance, house, and no, I cannot call it the same. Let's call this map. I like to call it map. This is what it is. So map and heater distance. And this map will have all means for every house to heater. Yeah. Then I will have this map, and then this will be first step. For the solution I brute force. First, we create map, all means for every house in here. Then we enumerate or loop house. Then loop heater, and then calculate distance from house to heater, and okay, let's call it calculate mean distance, and it will be like this. So we calculate mean between map and HDN, assign it to map H, else we add we just add HD to map. And then we will sort HD by value, a reverse sorting. And so it will be HD, heater distance. I need to sort it. Sort the HD items P equals lambda item equals items 1 reverse 2. And then we just return first element from HD. The first value return first of HD. So this is brute force. So time complexity on this will be O(n) power 2, and space complexity will be O(n), because I will be storing map. I created map and I will be storing everything in map. How we can optimize this search? So instead of looping here, we can use binary search. Binary search. Binary search. Binary search. In binary search will be the same. Instead of here, I will find closest heater. That's it. Closest heater in the house. To this house. So I will do index equal bisect. It's a function in Python that's doing binary search. Left, and we're looking into heaters, and we will find the house close. So this will be like index, and we still have to get so it will be closest heater to this. Yeah, for binary search, we probably have to sort. We don't need maps then, right? For this solution, because we can calculate result right away. We will store into variable and get max here. And result will be max result, because this will be already closest heater, so it will be mean to this value. It's already, so we don't need mean. Max between result and heaters. Heaters I minus h. We don't need this, and it's even, I like it, it's even shorter return result. I'm sorry. Okay, so this is nice. We're not gonna calculate, we just do binary search to find closest heater to a house. Perfect, I like it. So I'm not sure if I have to sort heaters. It's probably a good idea to sort heaters because there is no, we don't have if it's sorted or not. Okay, let's just, it's simple. Just heaters sort and that's it. Okay, let's try to implement this binary search thing. I do certain heaters, then for houses we search houses, search max, and return this. Okay, index out. Okay, so we need res equal max. Index out of range. So we got something. Let's print it. I believe it. We didn't. I didn't do edge cases. So what if bisect sometimes return like 4 if point in section point is not found. So we take house 1. We found closest heater probably 0, right? Or yeah. And we take 2 minus 1 and we have 1. Then 2, 2 is exact insertion point 0. Okay, let's print. I'm not sure how. Let's print time. It's probably because of 0. Or because if we get 3, 0, 0, 1, 0, 1, 2. Oh, heaters, there is no. Oh, okay, okay. So this is the edge case. We have to. There is a heaters only 0, so we don't have to. So we do if I equal calculate land heaters, call it LX. Yes, so we have to consider edge cases. If it's 0, we can get 0, but if it's lands, right? We have to take just else. So this will be else, and if we have a land, we just take max. Right? The last one. Just taking last one, and I wonder if we have to do like this if heater is outside on the right side, like here. And okay. Okay, yeah. So output 2, 0, 1. Oh, it's H case again. So for this house, we found this. And there's, it's okay. For house 1, we found heater 0, which is 1. For house 2, we heater 1, which is good. For house 3, we have found heater 4. Okay, this is my example already, right? Right? Oh, okay. I have to calculate left distance too. So here will be min. I have to calculate between two heaters distance minimal between two heaters. And it will be h minus 1. This. And for that, I have to calculate if it's 0, because otherwise I got error here, minus 1. So if it's 0, then just heater 0. All right. Okay, minimum, maximum, and then closed. Oh, max. Max. Okay. This is good. So this case will be let's address. Just need to see what it's in. So for 1, I is 0. So we just take first heater. For 2 is 1, 0, 1, closed. Oh, and for this case, we have to calculate what is closest for 2, 1 or 4, and this is what we're doing here. Okay, so it's working. Let's try to submit it. All right, and 78%. Let's see the fastest. Okay, houses insert. Similar approach. If house, hit. Yeah, between two heaters. Mean distance, max radius. Okay, but mean distance between two heaters. What is? Okay, this is why they add. Okay, they add. So if house on the right side of heater, while we found left side of the house heater. Oh, okay. Heater plus one. Okay, so they are like finding between two. Yeah, it's true. So there is another approach is to reduce instead of binary search, is to reduce amount of iteration between in brute force, because we have a house and heater on one line. So if we already found heater close to the house on the left and on the right, we don't have to consider any other heaters because they will be far, right? If you already have a first heater on the left, we already passed, and we found heater on the right. In this case, we don't have to go and see if there are other heaters because they will be far away and there is no point searching them. And this is why they added, okay, this is why they added infinity, like inserted first element, infinite smaller and infinite large at the end. So this will always run. Okay, yeah, this is nice. I'm surprised that this is faster. Okay, yeah, that's it for today. Thank you for watching.